Okay, so let's talk about that in a little bit more detail. Like, you refer to this inherent reasoning ability. You know, many people think about LLMs as doing reasoning, and we're going to talk about that a little bit later. But help me understand where you see the biggest limitations in LLM's reasoning ability is in terms of what the model does in an actual forward pass.
Yeah, and so I guess we go back to GPT-2. GPT-2 was this landmark architecture and paper that basically was just get next token, next token, next token, and it kind of worked. And like we just watched val loss go down, perplexity goes down, like the model just is more performant, looks better, starts to make some Shakespeare that actually sounds somewhat plausible.
Right.
And then we have to get these things to reason and to actually solve some really hard problems. And I've done extensive experiments on this, but like if you take, for example, sort. You have infinite amounts of unsorted lists and you give it sorted lists. You keep feeding it to the model, it should work, right? It's actually impossible for the model to map from unsorted list to sorted list. If I have
in a one-shot, basically.
In a one-shot basis. Yeah. It's like literally that we know a theoretical lower bound that for comparison sort, you can't do better than n log n steps. And if I have a list that's 31 characters or elements long, and my transformer is 30, I run out of steps to do comparisons. Right. It's not possible for me to like do all the steps that is needed to be done. In HRM and TRM, they use Sudoku as an incompressible problem. Similarly, and so are mazes. Those are incompressible problems. Rolling sum, incompressible problem.
So when you mentioned the sorting algorithm, when I think back to my algorithms class from college, the one way you could get faster than n log n in a sorting algorithm is if you had some access to an external memory cache. If you had some tape you could write to, then you can actually do faster than n log n by basically selectively putting things onto this memory. And I suspect that's a key limitation of these LLMs in that because there's no external memory tape inbuilt into the model, you lose certain performance possibilities in terms of how fast you can go.
That's right. And so I guess like radix sort would be like the most common one. You had like depending on the number of buckets that you have, you can kind of get from n log n to order n. You can't get less than n. You have to touch all the elements. Sorry, you have to do that. And if you run out of layers and transformer layers in your neural network, then you ran out of chances to do that.